55. I'm recording. Go back. It's going. All right. The homework for the B-Day. So somebody has already asked for number 9. So we looked at number 9. There's a picture of Adam put the food away.
There's a picture of Adam put the food away.
I've already said it 3 times today. Put the food away. Put the food away.
And this time it was me.
You're right. So here we go. That's the derivative. Do I have to do 7 and 8 in order to get to 9, Cynthia? Were you okay on 7 and 8?
Yeah.
All right, so I'll jump to 9. If f of 3 is equal to a negative 1, what is the value of f of 7? Well, if he's giving me a 3 and a 7, and I'm starting out with a picture of a derivative, how do I get f out of f prime? How do you get f out of f prime? The integral. So I'm going to have to integrate. Why am I writing with my finger? I'm going to have to integrate f prime of x.
That looks good for finger writing.
Wasn't bad, was it? And so my limits must be these 2 numbers here. He's probably using these 2. So that's 3 and a 7. And so without even looking at the problem, I'm just going to do this. From 3 to 7, that would turn into small f, if you want to call it, at 7. Plug in the top first, minus plug in the bottom.
How do you know which one's the top and which one's the bottom?
I like to keep the small one at the bottom. It's more traditional. That doesn't mean you have to. You got to remember, though, that if you're going to go from 7 to 3, and the answer will be opposite in sign than you were thinking. So I'm looking at 3 to 7. Look here. If I'm going from 3 to 7, everybody in here should know that the sign of the answer should be what? But if I wrote it from 7 to 3, the sign of the area would be what? Negative. All right. So that's how you know. You could do it the other way, but then you got to do an extra thought. And that hurts my brain. Okay. So now, he didn't give me the answer to the area. Well, actually, he didn't give me the answer, so how am I going to do it? I need to have a value. Oh, just do it with not Riemann sum, but with geometry, right? By the way, the geometry portions are still a type of Riemann sum. You're just not doing all rectangles or all trapezoids. In this one, I'm doing a trapezoid, a rectangle, another trapezoid. So I'll do my scratch work up here. This is 1, this is 2, this is 3. Let's see. If I do area 1, it looks like base 1 is the left side, which is a 2. And base 2 is the right side is up to how high? Hello?
2.
Nope.
Wait, which one?
Nope.
1.
1. And then I got a 1/2 of that, and then times the height. The height is this. 2. Yeah. That 2 cancels out the half. Yes. So I'm left with just a 3. Let me do piece number 2. Rectangle. Length is how much?
2.
Height is
1.
2 times 1? 2. So that one is about 2. Part 3. This is my base 1. How high is it?
1.
So it's 1/2 times the base, which is 1. And then 1 plus 4. 1 plus 4 is? 5 times the half? 2.5. Fine. So 2.5 plus 3 plus 2 is how much? 7.5? Yeah. And he told me f of 3 was already a negative 1. So, no, it's not 7.5? 3, 4, 5, 6, 7. Yes, it is. So we're looking for this f of 7. So I'm going to keep it. He told me f of 3 was a negative 1, all equal to a 7.5. That's really a plus 1. So how do I get rid of a plus 1?
Wait,
Yes.
7.5.
Area 1 was a 3, you said. Area 1 is a 2. That adds up to 5. Area 3, you said, is 2.5.
Yes, sir.
Joseph, you don't see 7.5 still?
You said area 1 is a 3. How is it a 3?
We had one base was 2, the other base was 1. That adds to 3. 1/2 times that times the height. Oh, the height. Was the height 2?
1.
Oh, that's the problem. Nobody stopped me on that. Where were you a while ago? That's a 1. It doesn't cancel out the 1/2. All right, so that's, Lacey saved us before we finished it. So it's really 3/2. Try it again. 3/2 plus 3.
There's 6.
Call-
All get together 6.
I know, but don't jump ahead because then they're waiting to hear 3/2 plus 3 is 4.5. 4.5 plus 2.5 does add up to 6. So 6.0. I'll just change it to that. Now I got to still get rid of this minus minus 1. How do I get rid of it? Andrew, stay with us, man.
You subtract it from 6.
Yeah, subtract it. So f of 7 is how much?
Is that like your quote for today?
F of 7 is how much? 5. Where'd you get stuck at, Cynthia?
I was just confused on how to start.
Okay, fair enough. They are difficult problems. Anybody else? Anything in the homework?
That's pretty fast. I understand this. I
This is
understand
not
that you're
about
grading.
homework because of the quiz.
Don't have trouble.
Okay.
I'm good.
You're supposed to do the homework first, then the quiz. Okay, well, it all works out.
Why are we supposed to do the homework first?
To practice it before you take a quiz. Anyway.
Oh, what do you mean? We're taking a quiz?
No. Anybody else, guys? Come on. B-Day's depending on you to pick something
Beat it. What do you want?
Something for what?
because they're going to get this video.
Can you do number 10 then?
10.
Yeah, I was going to say that.
The graph of f prime, the derivative of function f of x is pictured below. Okay, again, graph of f prime. Please, I got to remember that. From -2 to 6, that looks pretty good.
Pretty good.
Right, and find the value of a definite integral to find each of the indicated values below. Also, FYI, f of a -2 will always be considered a 5. Interesting. Remember, that's not f, that's f prime. So, number 10, find the value of f of 0. So, this is what I'm going to do. He wants me to find f of 0. I already have f of -2, which is 5, right?
Sorry, sir.
Is it, Gavino, is it?
Huh?
Is it?
Is it what?
Yeah, is it what?
Sorry.
The
sir.
question I was asking. It is a 5.
Five.
So since they gave me these two functional values, or at least I want this one at least, I'm going to probably think of my integral being probably the smallest, a -2 to a 0, of f prime of x. Of course, dx. Now, we all know what this means is when you integrate f prime, you get an f, do you not? You get an f of x, and we're going to go from -2 to 0, which is why in the other problem I jumped right to this. F of 0 minus f of a -2. And so this has to equal to something in order for me to solve this for f of 0. Well, I got to go to my picture then. 0 to, or -2 to 0 would be -2 to 0. Oh, it's just this one triangle. What's the area of this one triangle? This area is base times height divided by 2, which is 2 times 4 divided by 2, which is 4. So that's what I put right here, 4.
Yay.
So I'm looking for f of 0. He says f of a negative 2 is a 5, equal to 4. So I have to add 5 to both sides. F of 0 must be 9. Yes? I'm just going to set 11 up for you. I'm going to set it up. We know f of a negative 2 is 5. He wants to know f of 6. So those are the two pieces of my definite integral. Integrating from negative 2 to 6 of f prime of x will be f of 6 minus f of 2. I have to set that equal to the area of that I do by hand. 2 to 6. 2 to 6. It's a half a circle. And it's underneath the x-axis, so it's negative area. So if this was a full circle, area would be pi r squared, but I'm dividing by 2, so let's try it out.
Wait, if it's a full circle and the bottom half is negative and the top half is positive.
Well, I'm not doing the top half.
Yeah, but if you were.
Oh, if I was, it would no longer be a function. So you would have to, if they asked you to find the area of a circle using calculus, you'd have to break it apart into two separate functions, one with a positive arc and one with a negative arc. And then you would say, based on the fact that one's above, it would add up to 0. But what if you just shifted the circle up? Then you could be all positive area. So yeah, you're thinking much deeper. Anyway, pi r squared h. What is r? From here to here. 2. Pi times 4 divided by 2 is how much? 2 pi, isn't it? So all of this is equal to 2 pi. F of 6, I don't know, minus a 5 has to be 2 pi. F of 6, oh, how did I do the whole thing? Is 2 pi plus 5. Anybody else? Last chance. We did. Well, I don't know. We did all of those except for 2.
Why divide plus 5?
Because f of 2 is, f of negative 2 is 5. Oh, did I use the wrong number? Yeah, it was f of negative 2 is 5. That's given in the problem. But did I write the, yeah, I went negative 2 to 6. I did it right. I just didn't write the negative on that one. That was given for us. So I just plugged it in.
That one, isn't it supposed to be 4 like minus 2 pi?
4 minus 2 pi? Where are you getting a 4?
Because from the triangle.
No, there's no triangle in this piece.
It says from 0 to 6.
Oh, I went from 2. Yeah, I went from 2. I'm going to tell you what. This is a freebie. We're going to say, yeah, no, I got to erase it. I can't even cheat. You got to give me an A for trying to cheat.
Yes, sir. Like that.
Joseph, why do you always wait till it's all done? Every time. Every time. You never stay with us and say, that's not right.
It's because you move on and he's still questioning whether or not.
Well, yeah, but he knew from the beginning that it wasn't at a 2. Not necessarily?
Sometimes you get lost for a little while,
Oh.
and you have to try to find
You get lost in your own head.
Got to find your way back home?
Yeah.
Oh, okay, I buy that. All right. The picture was that, but it's also going to be the whole triangle then, right? All right, we write it again. Oh, it was looking so pretty. I was too. Negative 2 to 6 of f prime of x dx is going to be the function from at 6 minus the function at -2 equals to some area.
So taking the victories.
The noise, guys.
Sorry, sir. I apologize for the amount.
Okay, so I do have to add the whole doggone triangle. The good news is, though, we already knew that the blue triangle was how much? That was the answer we did over here.
2 plus 4. I mean, 2 times 4 is 8. Half 4. I think. 1/2 of.
I think it's 8, because this was a 4, wasn't it? Or no, this was a 2. Which was it?
The base is
2 times
the height
4.
is 4, and then 1/2. So.
Okay, 1/2 of the base. That would give me 1/2.
You're doing the whole thing.
The whole thing now.
Oh yeah, that.
The
is
whole
8.
enchilada. Okay. So it actually is going to be 8
The whole enchilada.
plus 2 pi.
I'm doing some more.
Is that right, Joseph? Joseph?
Yes.
8 plus 2 pi?
Wait, sir, I think I did something
So
wrong.
did you know Joseph won most likely to break a world record?
Oh, I believe it.
You should have won. You should have won.
All right, so, yes.
Most athletic.
Oh, good call.
It's gonna be a.
8 minus 2 pi. It is 8 minus 2 pi, silly people. So
Silly rabbit.
tricks are for
Kid.
kids.
How does that
Equals to 8 minus 2 pi. Now add the 5. Yeah, I guess you were wrong too, Joseph.
Wait, why?
Because it's really going to give me a 13 minus 2 pi.
Which one? The what? The whole answer?
Yeah.
I was talking about the whole answer. I was talking about that other part.
What? But you didn't say it was 8 minus 2 pi.
No, I was talking about the whole answer.
What is the whole answer?
No, I was talking about the area. I thought the area would be 4 minus 2 pi. Of the,
But it wasn't.
why is it 8 minus 2 pi?
What's the area of this whole triangle?
It's 4.
Why?
1/2. The base is 2.
No, the base is 4.
Doing the whole thing together.
It went from -2. You're the one that caught it that I didn't go from -2.
The yellow and the blue.
Huh?
Why can't you just use the yellow part? Because you already found after 0.
You got it. You have to start from beginning and do the whole triangle.
Why? You already found after 0.
They're not the same in every problem. Because look at the words. It's always if this is true. It's not, you should get the same answer
Where does it
in the ones I did as a lecture. We didn't change it. He's using this. Because you have to go use the limits that are here. You can't start at 0. I don't think it'll give you the same answer. Because what was our? Yeah, I'm pretty sure you got to start from the 6 and the -2 because every scenario is different. All right, enough of that. That was enough fun to kill her. All right, you picked up a new packet. Well, you're the one that. But you still were giving the wrong answer, though.
How? It's the right answer.
You should have the same answer as us.
I do have the same
Okay.
answer. 18 minus 2 pi.
Okay. 8 minus 2 pi. All right, new packet you got out. You picked up from the podium.
Moving on.
Moving on, fundamental theorem of calculus.
Wait, so since we're moving on, we're not going to have to go back to this one.
No, we're not going to go back to that necessarily, no.
Not even.
Oh, but you got some AP problems still in there that we have not discussed.
Oh, right.
So, no, I'm going to teach particle motion.
We're going to discuss it next time.
Yeah, next time, when I can be here for both A and B day. All right, things to keep in mind. Adam, here are things to keep in mind. If you integrate velocity, then the integral of velocity must be one step below, which would be position.
But how do we know that if we're not in physics?
Well, because we've talked about that the derivative is velocity, right? So if the derivative of function is velocity, and we said the derivative of velocity is acceleration, right?
Can you write that down like in order? Because I don't know which one's higher than which one.
Okay, we'll do this. How about this? If you start out with a position function, I'm going to call it x of t.
Okay.
Let x of t be the position function. If I take the derivative with respect to x, I guess, d dx, let's see, of x of t, that is x prime of t. That is called velocity. If I do another derivative, and so now I'm taking the derivative of x prime of t, which really means I'm taking the derivative with respect to, of the velocity,
Velocity.
that equals to acceleration. If you go backwards and you start out with acceleration and you integrate acceleration, you end up getting velocity.
Yay.
So you're going back down.
If you integrate velocity, you end up getting position. That's right.
If you integrate position, you
So-
end up getting
Yeah, what happens if you...
The derivative of position, I don't think it has a name.
Wait.
There is a name for the derivative of acceleration. We've talked about that being the jerk.
what's it? But the integral of position.
Yeah, what happens if you take an integral of like the original function?
The integral would be it's still going to be an accumulation underneath that function, but it may not have a name because I don't know what that function means. But in a sense,
And on the graph?
well, you're going to get the integral graph. You're going to get a function that's an integral, but it may not have a name because of the situation. We're just giving these names because it's acceleration, position, and velocity. So here we go. If you integrate a to b of velocity, the antiderivative velocity is position. He used the p just to stand for position. Obviously, you plug in the top and you plug in the bottom with a minus. So that's something that you should know, but it's not intuitive necessarily. If you go and integrate velocity, the antiderivative velocity is going to be a position. Let's see, he did velocity up here. What am I missing here? Oh, I went down. When you do P of B minus P of A, it also is the net distance that a particle traveled from A to B. It's the net distance because it was the integral. The integral sign always means you're adding something up, like area. True? Well, when you integrate velocity, the area underneath it stands for the accumulation of position. It means you've added up distance, which is why it's called the net distance the particle traveled. If, by chance, you're accumulating under the absolute value of velocity, it's the total distance. Now the question is, what's the difference between net distance and total distance? If I have a function here that looks like that, and let's say it's a sine curve of some sort, then you know from experience that this piece here is exactly the same amount of area as this piece here. Would you agree?
Yes.
So the net distance from A to B would be what? 0. The net distance would be 0. But if you did the total distance, this is like saying, okay, Cynthia's going to walk to the wall, and then she's going to come back where she started, and we're going to say, well, how far did she actually get from home? And you're going to say,
0.
0.
Why?
Because she's still home again.
That's displacement.
But if she goes to the wall and she's got a pedometer that doesn't care which direction you're going, and she walks 2 miles that way and comes back 2 miles, are you going to say, what a wimp, you only walked 0 miles? No, you're going to say, you walked 4 miles. Because what absolute value does, in your pre-calc class, when you graph the sine function as an absolute value of sine,
What if you're
Yeah,
walking in
'cause it's-
place?
what?
And you're not going
You're not going anywhere.
It's like a
But
pendulum.
you still walk?
Yeah, but you didn't make any distance.
But that
Your pedometer would give you
I already did, but
steps.
I'll do it with you.
So when you do the graph of sine of x absolute value, this part looks identical. Looks identical, but then this part jumps up to here. When you graph the absolute value of the sine function, you will not see anything underneath the x-axis because the absolute value of something is always positive. So that's why when Cynthia walked 2 miles that way and walked 2 miles the other way back, she did a total of 2 and 2 is 4. It didn't cancel out because the absolute value shoves that function up on top. You don't even have this piece anymore.
Got it.
So that's why he said, if you want total distance, then you need the absolute value of the function. If you want net distance, do not absolute value it. You want the negatives to cancel out the positives. Number 1, the velocity of a particle, which is moving along the x-axis, is given by v of t equals 3t squared plus 6. This is a non-calculator question. If the position of the particle at t is 4 is 72, that might be important later. What is position when time is equal to 2? Interesting. We know where the position is at 4, but I don't know where it is at 2. So to get the position function, I have to take the velocity function. I'm going to have to integrate it. And I already know, I'm actually going from, so how can I do this? This was at, what did he give me, 4? Well, we already know that answer is going to be, if I go from 0 to 4, let's see, moving along the x-axis, I'm going to do that. 0 seconds to 4 seconds will be the position function at 4. You know what? I can't go to 0, so I don't know anything about 0. How about instead of 0, I go to 2? 2 to 4. Does that make more sense? That way I go minus position at 2. Now the question might be, is what would that total distance have been? Well, I got a function up here. So that's the function I'm going to use. Integrate 2 to 4 of 3t squared plus what, Talia? That's good. dt. Do the integral. That's, what is that going to give me? 3t what? 3t cubed. Well, is it? 3t cubed divided by 3. That's right. That's right. Plus 6t. So, and then I'm going to evaluate this from 2 to 4. Which is why we have the 4 plugged in than the 2. So that gives me 4 cubed is how much? 64 minus 6 times 4 is 24 and minus 2 cubed is minus what? I don't know. Where? See, yeah, 6 times 2, yes. How much is that? 12. Oh, you're right. Good catch. Say again? Right here? Yes. My minus is here, though, right? Okay. That's 88 minus 10, 78. Now, 8. Yeah, I thought it was a 2. 20. 68. So what I do at 68? Because what was the question? The question was, what's the position at 2? Well, do I really know what the position was at 2? I know what it was at 4. I didn't know what it was at 2. So can I use this answer right up in here? Yes. 68? Because that is the P of 4 minus, that was what I just did. And if I already know P of 4 was 72, then I'm going to write it out in case you got lost here. 72 minus P of 2 must be 68. Negative P of 2 must be negative, how much? Negative 4. P of 2 must really be 4. You see all the work that was involved? You had to integrate for real, not find it with the geometry. That gave me the 68. We had to plug it back into the equation and solve it for the missing position that I didn't know. Let's try another one. What's the total distance the particle travels on the interval from 0 to 7? 0 to 7, total distance would be the integral of v of t dt. Anything else I need to know? Total distance? Somebody better tell me, or I'll do it wrong. He wants the total distance from 0 to 7. Is this correct?
Absolute value.
Oh, absolute value. Absolute value of that. So that becomes 0 to 7 of the absolute value of 3t squared plus 6 dt. So what does that imply? Any negative area you had actually becomes positive area. He did say this is non-calculator. What does that look like? If it's non-calculator, I'm going to be looking at this parabola. 3t squared plus 6 look like this. Didn't it? Hello? I mean, the origin is here. I mean, the vertex is here. Does any of this function from 0 to 7 ever go underneath the axis? No. Double check it, please. Check it with your calculator. We're just going to double check that this graph would look something like this from 0 to 7. Yes. So the question is, was absolute value even necessary? No. But I wanted you to still put it, if this is truly the graph, and I think it is, always put it there, because just in case it was an upside down parabola and it were shifting underneath the axis, then you're going to have to flip it over the x-axis. So anyway, I think the answer is just going to be, you're going to integrate the same, t cubed plus 6t from 0 to 7. I don't even know what That's going to be, plug in the 7 first. What's 7 cubed? Somebody? 7, how much? 343 plus 42. All of that minus how much? I love it when 0 is the bottom limit, because what it turns into? 0. I believe that would be the answer if you do the adding. 385? Yeah.
Can you go back up to that second one? What did you do after you got 68?
I plugged it up into the basic integral we had, p of 4 minus p of 2, and I set it equal to 68 because we knew p of 4. P of 4 was given to us as 72. I don't know p of 2 for sure, but I know the total answer was 68, so I just solved it right there. At least I hope. Nobody's...
No, yeah, it's right.
Well, Talia says it's right, Joseph. And I hope that's the right answer here. Let me phone a friend. Hello, Andrew.
Andrew, is it right?
Are you there?
Confirm with us.
Do you agree with our answer so far? Oh, thank you, Andrew. Okay. I love that show. Ever watch that show where they phone a friend?
How to Be a Millionaire.
Yeah.
Oh, isn't that fun?
You know, there's this little bird that's always out. Did it give you this answer?
Yeah.
Oh, cool. Oh, but be careful because we didn't change f of -2. That was why. He could have said, though, in the next problem, f of -2 could be equal to 6. You know, no, you're right. That's who I'd call, though. I'd call Andrew. All right, number 2. This is a calculator problem. This is a calculator problem. The velocity of a particle that is moving along the x-axis along this function. Okay, look how ugly that function is. No kidding, calculator. If the okay, it's reversed now. If the position of the particle at t equals 1.5 is this decimal number, what's the position at t is 3.5? Well, we do it the same way, guys. I'm integrating, and the only numbers I have are 3.5 I'm interested in, and I have 1.5. So wouldn't it make sense to integrate the position from the 1.5 to 3.5? Because we know that's going to be p of 3.5 minus p of 1.5. If only I had the answer. Well, calculator. We're going to do this with a calculator. We are going to integrate that ugly function right here with a calculator because he said it's calculator. So now the bad news is, you guys that are listening, when I turn this off, the recording pauses, you're on your own. Do it on the calculator. I will continue with part C. What is the distance the particle travels, the net distance the particle travels from t equals 0 to t equals 10? Now, net distance, you have to remember that it's not the absolute value, because going left and going right the same amount of spaces would cancel each other out. Your net distance would be 0. But in this case, we're going from 0 to 10. So from 0 to 10, we've got some positive distance and we have some negative distance. So we're going to have to take the positive and subtract the negative. Whereas in the last problem, I don't think we actually finished B.
in class. So I will do B after I finish up with C. Okay. Now reminder, this graph was the velocity graph. The area underneath velocity is distance, because when I integrate velocity, you get position. I can't remember, we're using P. We'll get P of T. So the top is just a trapezoid. So I'm going to do area will equal the trapezoid, which is 1/2, times the two parallel sides that are called bases. And one is 6. And the other one looks like it's between 2 and 4, so that'd be 2. And the height of this trapezoid is this distance here, 5. And then I'm going to subtract the area of this triangle. Well, the area of this triangle is 1/2 base. Looks like it goes from 6 to 10, so that's 4. The height of that triangle, this is where the negative comes in. See, it's actually a -2, I think. So I'll just leave it at 2 because I already put the negative on the outside. So the net distance the particle traveled is 8/2, which is 4, times 5, minus 8/2. 8, so that gives me -4. So my net distance is a positive point, oh no, I'm sorry, positive, that's 20 minus 4, positive 16. And you would label it as units. And it makes sense that it's a positive answer because I have much more positive area than negative area. All right, so let me go over here to B. I thought I had finished it, but now I remember the bell ringing class, and so I'm actually touching this up to have a complete set of notes for both second period and third period calculus students to get the assignment done. All right, what is acceleration when t is 5? So if we're looking at the velocity graph. Oh, I know what I just erased was silly. The derivative with respect to t of vt will give us the acceleration. Well, maybe I had the answer there. I just didn't pay attention. I did have it on there. So the derivative at t is 5 means what's the slope at 5? Slope at 5. When I looked over here at 5, yeah, I did do it because when I looked at 5, I see that we're on that line, and the slope of that line is rise over run. So it looks to me like, I don't know if it's rise is 5. It's a negative slope. The run looks like 2, 5/2, and I'll have to say negative. So would be equal to a negative 5/2. And acceleration would be always in unit per second squared. D. What is the total distance traveled? Ah, wonderful. I'm going to use part C's work because when let me erase my picture up there so you can see something if it'll let me. Yeah, it's going to let me really good. When you want total distance, the beauty of this is that you're absolute valuing the whole function. Well, when you take an absolute value of a positive function, which is this piece up here, it stays positive. But when you take the absolute value of a negative function, it pops it up as up here, so it becomes positive. So it's the same work as in part C, except this time the 1/2 times 6 plus 2 times 5. It'll be a plus because when you absolute value, every negative part becomes positive. 1/2 times the 8 This is, of course, assuming I have all the numbers correct. I'm sure somebody will let me know. So 8 divided by 2 is 4. 4 times 5 is 20. 20 plus 4 in this case now would be 24 units. See how it's different? It's accumulated more. The other one, let's see if he ever said that. It would have been nice if he said, no, he didn't get any units in that one. So too bad, so sad to be him.
No.
All right, continuing the notes. This is in table. This table is the velocity. So it's no different than what we just did, except we're looking at it was a table. V of t is in meters per second. Now at least we have notes, units. Do we have note units? This one, it is in meters per second. The particles move along the x-axis at selected values of time. Okay. So I'm ready to go. What is the value from 0 to 18 of v of t? Well, if you're integrating v of t, then again, you're finding the total distance. And since there's no absolute value, I'm sorry, I shouldn't use the word total. It'd be net distance. So I don't know if he wants it in the answer. I'm going to write it out though. Net distance. Particle travels. Is, and I'm going to do it. I'm going to look at that graph. I'm going to say, okay, I'm going from 0 to 18. That's the whole thing. Well, okay. He's not asking me to do it right now. He just wanted to know what it was called. How do I know? Because I was going to ask you a question. It's an estimation because you don't know what's happening between 0 and 3 or 3 to 6. So you'd have to be doing this as ordered pairs that were graphed, and it would look something like this: 0 to 1, 2. How far will I go? Well, I can even make it better. 0, 1, 2, 3, and 0 to 2.3 would be about here, and 3, 1, 2, 3 goes up to 2.7. And then 6, 3, 4, 5, 6, up 2.6. So you see what's happening here. 9, 6, 7, 8, 9, 1.3 goes down to there. 9, 10, 11, 12 goes up to the 1. 13, 14, 15 goes up to 1.7. And then 18, that's 16, 17, 18 goes up to 2.1. That goes back up to here. So, those are all just pieces. And I'm going to use that picture in just a second. He says, be using left Riemann sum of 6 subintervals of equal length. Estimate the value of this integral. And that's what I was saying, it's going to be an estimation. He wants left. He wants left. And I've got 1, 2, 3, 4. See the overlap? Remember what we did before? Those two. Now those two. Now those two. Now those two. Now those two. And those two. The right becomes the left of the next piece. The right becomes the left of the next piece. So if I'm using, he'd say he wants the left Riemann sum. So I'm going to use what color? Red here. I'm going to go up to here, up to the first one. Each of those stands for an interval. So I'm just going to cut over to the right to where that number is. So it goes about right here. Come down. That would be that one rectangle. The next one to the right. Let's see, I don't know if I messed up on that. Yeah, I did a little bit. I'm not a good artist. To the right. 1, 2, 3. He counted by 3 each time, so 1, 2, 3, so it's about here. Then to the right, then to the right, to the right, oh, messed up, to the right. I think I messed up before that. Yeah, I got messed up because this one should have went this way, like that, and down, and this one went that, and down, and this one went that, and down, and then this one goes that, and down. You got the idea, I think. And then the height of this last one, that's just the last one, so you actually would have lost it. Something like that. Bottom line is, the right side is the x and the height of that rectangle. So area will be approximately, by the way, each of these distances, 0 to 3, 3 to 6, 3 to 9, 9 to 12, is my length times width. My widths are all the same, so it's a 3. So all I really need is f of 3, is the first one, plus f of 6, plus f of 9, that becomes the right of the other one, plus f of 12, plus f of 15, plus f of 18. That should be 1, 2, 3, 4, 5, 6, using the right side for each one. I don't know if I drew that picture. Yeah, I kind of, I didn't use the right side. I drew the picture of the left. Now I just feel so bad. I want to do the whole picture over again. I'm going to, because I don't want, I just get excited with the actual mathematics, and I didn't put pride in my picture. So let me do it again here. 3, 6, 9, 12, 15, 18. That's it. And I didn't go much higher than 2, so 1, 2. So 0, 2.3, about here. And then 3, 2 points. Oh, yeah, I did have to go up higher. There's my 3 if I needed it. 3 goes up to 2.7. So that will be about here. That was the 2.1. 6 went up to 2. 6 went to 2.0, so boom. 9 went up to 1.3, right here. 12, 1.6, a little higher. 15, 1.7, a little higher. 18, 2.1, a little higher. Using the right side, let me do this better. Using the right side, go left. 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 There. Oh, I feel so much better now. Okay, that's more pride. And if I was to try to connect those original dots, though, it looks something like this. We're not even assuming that what kind of curves could have been there. All right. Anyway, back to the task at hand. That was, the area was 3, and the heights were for each one, starting at 2.7, then a 2, and then a 1.3, 2.7, then a 2 and a 1.3. After the 1.3 was 1.6, 1.7, and 2.1. 1.6, 1.7, and a 2.1. Add that all up. 2, 4, 5, 6, 7, 8, 9. 9.8. I believe it added to 8.9. 3 times 8.9. And if I'm wrong, you can sue me in court. 27, 24 divided by 26, 26.7, and the units would have been, he said it was meters per second for the velocity, so this should just be meters. Please let me know if there's a mistake. Using right Riemann sum in 6 subintervals of equal length, evaluate. Wait, what did I just do? Oh, shoot. I wasn't paying attention. Oh, okay. I'm going to change this word to, I'm going to change this to right. I knew I was on the right one the first time. Right. This one I'm going to do left. All that changes. The work's the same now. Area will be approximately a 3. This time I start with the f of 0, and then I jump over to f of 3. Then I do f of 6. Then I do f of 9. And I do f of 12. And f of 15 would be the last one this time because it shifted over. So the only difference is now the number starts at 2.3. 3 times 2.3 plus 2.7 plus a 2 plus 1.3 plus 1.9 plus 1.7. I'll let you do the adding up. Use the midpoint. Sum of 3 subintervals. Only go, well, now use the midpoint Riemann sum of 3 subintervals of equal length. Okay, so that's a little different. Let me erase my annotation on the table. What's happening on top of this graph now, if you really want to know what's happening here, is we are changing it to 3 intervals. And midpoint. So let's see. That would be having a midpoint. And that would be a midpoint. That would be a midpoint. And then that would be another midpoint. And so what you're really having is now this midpoint here, which was this point up here, you have that rectangle. And this midpoint, boom, boom, like that. Then this midpoint, boom, 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 boom. So now you got this rectangle, and this rectangle. So it's the 3, 9, and 15. So, and the distance this time is 6. From 0 to 6, 6 to 12, 12 to 18. So this area, this is just a review of Riemann sum. 6 times f of 3 plus f of 6 plus f of 9. And the table had f of 3 was 2.7, and f of 6, is that what I did? F of 3, no, it was f of 3, f of 9, f of 15. What am I doing? F of 9 and f of 15. Let me just erase it. That won't let me. So I have to write on it. F of 15. So 3, 9, and 15. I'm sorry, I circled them. 2.7 and 1.3. And then the 1.7. That sum times 6. I don't have to put equals, it actually is. 2, 3, 4, 5. 5.7 times 6. Which is 42, 34, 34.2, again, meters. Use trapezoidal sum of 6 subintervals of equal length to estimate that. 6 subintervals of equal length. Okay, what am I going to do? Well, it's the same as the rectangles when I had 6 of them, but I'm looking at it slightly different. Let's see, will it let me erase up here? We're in luck. And each one's important. So now 0, 2.3 was important. 3, 2.7. I don't know where. Let me try to erase that. It won't let me. Oh, I didn't hit it. It's 2.7. It's up there. Then a 2 for the 6. 9 was 1.3. 12 was a 1. 15 is a 1.7. 18 is a 2.1. So when I superimpose my trapezoids, each one is a trapezoid. That isn't very straight. Boom, there it is. And then that one. Boom, there it is. Boom, there it is. We always connect. Each dot now gets to be a side of a trapezoid. There they are. Nice and pretty. So the height of each trapezoid is 3. The height of each trapezoid is 3. And that would be, remember the formula. It would be, area would be approximately 1/2 times the height with all the bases. There's the first one on the left, which is going to be an f of 0. F of 0. Then you're going to have 2 f of 3s, 2 f of 6s, 2 f of 9s, 2 f of 12s, oh, that ain't gonna move. Oh, no, I don't want to erase all that. I want just that one piece. Oh, I did it. Plus 2 f of 15s. And just like the other end, only 1 f of 18. Oh, I did lose the height, which was 3/2. Area is approximately all of fun. Now find the average acceleration of the particles from 3 to 9. Average acceleration. Well, remember, this is a table of velocities. So I have to do the average acceleration, which is like the average derivative. Average acceleration, since acceleration is the derivative of the velocity, and you're going from 0 to 9, that's just a secant line. So you could look at it as going from 2 points, x is 0 and 9. At 0, 2.3, and 9 was 1.3. 2.3, and 9 was 1.3. So when you do average derivative, it's always just the slope of the secant line that connects the endpoints. So average acceleration will be slope formula, rise over run, f of 9 minus f of 0 over 9 minus 0. And that is f of 9 was 1.3 and 2.3. I already wrote that down. Why am I looking again? 1.3 minus 2.3 over 9, which is negative 1/9. And average acceleration would be, was it meters again? Meters per second? Yes, that was velocity, so it's meters per second squared. Oops, I didn't read it right. It's 3 to 9, not 0 to 9. So it's f of 9, f of 3, 9 minus 3. F of 9 was 1.3, but f of 3 is 2.7, sorry, 2.7. And that surely is not a negative 1. Oh, what the heck. I'll just cross that off. That would be, if I do the math, negative 1.4 over, not 9, over 6 meters squared per second. No, meter per second squared. And you can do that decimals. Now I'm looking up here at that number that I did that, the left. Let's see, what one did I actually add up? It was a right Riemann sum. Let me make sure I got the right numbers there. F of 3 and f of 6, since I'm seeing wrong, was 2.7 and a 2. 2.7 and a 2. Then it was a 1.3 and a 1. 1.3. Ah, this was not here. It's supposed to be a 1.0. Okay. Then it was a 1.7. There's that 1.7. That's fine. And then the f of 18 is 2.1. Oh, 2.1, yes. So if I add that up again, 2, 4, 5, 6, 7, 8, 8.8 times 3. 8.8 times 3, 24, 25, 25.4 instead. Meters. I'll triple check it. Who knows? What else? That's a good page. Okay, this is an actual AP problem from 2001, worth finding, worth doing. Looks like they think you could do all 4 parts. A car is traveling on a straight road with a velocity of 55 feet per second at time t is 0. And time goes from 0 to 18 seconds. And it looks like the car's acceleration, a of t, is in feet per second squared. And it's a piecewise linear function defined by the graph above. Okay, so that's the acceleration of the car. A of t. Interesting. That's the acceleration. So you can see he has positive acceleration until he gets to 6 seconds. Then the acceleration goes negative, which means he just changes directions. Still accelerating, just the other way. Is the velocity of the car traveling at increasing at t equals 2? Well, at t equals to 2, what he's asking you for is the velocity. Well, the velocity is the integral. So if you're going to 2, he's asking you, are you increasing area at 2? Because when you integrate a of t, that gives you v of t. So if you're integrating up to here, you're basically adding it all up to a of 2 would be, v of 2 would be that total. So accumulating area. Now you can see I'm accumulating area all the way to 6. It isn't until I get past 6 I'm taking area away. So keep that in mind. At what time in the interval, other than t is 0, is the velocity of the car 55? Well, we know at 0 is 55, but there's no picture to the left of it to accumulate it in the area. So you'd have to take his word that at 0 he was at 55. So what you're going to have to do for B is you're going to have to accumulate area. And I know at 2, the area is only 2, that's a rectangle, 2 times 1, that's 3. So that area right alone, I'm not going to do it all for you, but that's 3. Then I had a triangle here, right here. See that triangle? 1/2 base times height. 2 to 6 is a 4. Half of 4 is 2. 2 times 1.5. Well, that's also 3. So there's 6. Gotta keep on going. Gotta keep accumulating and find out if there's a place on that curve where I'm adding up to 55. So you keep going. Find out. Play with that. You have enough to get the homework done. Okay, I'm looking at this. It's not a 3. That's not a 1.5. It's 15. This is 2 times 15 is 30. I'm going back to that second one. This was a length of 4. Half of that is 2. 2 times 15 is 30. So we know we start out at 55 here. We were at, he said that, where was it? Starts out at the initial velocity is 55 feet per second. So before we even start looking at the graph, it was 55. But I've accumulated now 60. So I'm going to the right. Keep going. Now I'm going to have to take away from the, I want to get a total of 50. So right now I got a 55 starting out, plus a 60. Let's see if, that would be hard to find that area. Let me go find that area. It's just another triangle upside down. 6 to 10 is 4. Half of that is 2. 2 times 15, that's 30. That's a negative 30. And that takes me to the next easy spot, probably would be here. That's 2. Another negative 30. Add that up, you're back to 55 again. So there it is. There is your B. We said A, it was increasing. Why or why not? Because at T is 2. You had positive area. That meant positive velocity. So it was increasing as you went to the right. It keeps increasing. It keeps increasing. It keeps increasing till you get to 6. Then the velocity starts decreasing. At B, we accumulated the area from left to right. And what time interval the car's absolute maximum velocity? That means what's the most velocity the highest value it's ever going to be. Not it's like the absolute min, absolute max. So what you have to do, you have to keep on going, like I just did. Keep adding up, adding up, adding up. Find out if you're ever going to get higher. Right now we're at 55 again. So our highest that we were so far was 55 plus 60. That was our highest up to here. So that could be the most. And then when we took away 30, you're going to take away another 30 here. So now you're going to be down to 55 minus 25. You're going to take away some more, then we're going to add some more. So I think I've almost answered that for you. At what time is the velocity, if any, is the car's velocity equal to 0? I gave you that answer already. There was that spot where the area adds up to 0. I'm not going to give you any more help. Work on it. If you have to cheat, you can find them. They're always telling you where they're at, but I want you to play with it and write a book per part. Oh, there's your homework. Day 55. So it's 5 problems. Okay, there's your homework. I'm done. Adios. Bye. And another 6 problems. Oof, it's a long one. Yep. And you got another for response to play with. That's a new set of notes.